school's out, blame corona, but I still got some science I could show ya. No class, no school, that's cool, throw the class on the YouTube. Even if they shut the school down, I'll get that knowledge anyway somehow. Real scholars won't stop for corona. Tune in for that science takeover.
Happy Thursday, everybody. Welcome to Mrs. Finney's science class. Shout out to our HB warriors, to all of our subscribers, and to all of our visitors. From my home to your home, let's talk about science. Today's lesson, we are still in lesson 7, and we're wrapping up with a reading section for lesson 7. It's titled Parts of a Cell. Section is called Reading Further. Swat those germs. All right, so we want to get into this lesson. And let's start from the very top. It says, look out, germs are everywhere. And we are very aware of that at this day and age, right? If our eyes could magnify tiny objects like a microscope can, we would see how disgustingly covered with germs the world is. But wait, if everything is covered in germs, why don't we get sick all the time? All right. Surrounded by germs. Imagine that you live in a large city and you take the subway to school. How many of you have ever been on a subway? Please drop that in the comment section. As you walk down the stairs of the subway station, you hold onto the handrail, which is covered with germs that were deposited by other hands. The platform is crowded with people, all breathing germs into and out of the air. The train arrives and you find a seat, which also is germ covered. You cannot get away from these pesky microscopic bacteria, viruses, and fungi. Not all of them are germs, agents of disease, but those that are germs can make you sick. Here's an image, a public subway system, okay? And it says this is home to billions of germs, including bacteria, viruses, and fungi. People are bombarded by germs on the things they touch and in the air they breathe, but they do not get sick all the time because the body has its own defenses. You gotta fight, all right? So here we go. Germs have to enter the body before they can cause disease. They have to enter the body before they can cause disease. And there are ways to keep them from entering. Germs on the handrail and train seat are kept out by an outer barrier of skin. Shout out to our skin. Yes, does a big job for it. Hairs and mucus in your nose actually have a purpose. Trap airborne germs so that they can be sneezed out of your body. If any get into your airways, you can cough them out. Okay? Skin, nose, and airways are your body's first line of defense against germs. But what happens if the germs get into your body through a cut in your skin or make it past your nose hairs? You don't have to worry. Your body has a second line of defense. All right? So here we understand we have a first line of defense for germs. Skin, nose, and airways. That's our first line of defense. Let's look into the second line of defense. The SWAT team. Each of us has something like a SWAT team working inside the body to kill germs that make it past the first line of defense. A SWAT team, short for Special Weapons and Tactics, is a group that is trained to deal with risky situations. Instead of soldiers, your SWAT team is made of different kinds of cells, each with its own weapons and tactics for fighting germs. Right? These cells are part of your immune system, which is made up of specialized blood cells. How might your SWAT team members battle the germy invaders? Suppose you had a cut on the hand you used to hold the subway handrail. hand, subway arrow, okay, maybe a cut, and germs were able to sneak into your body. Sneaking in. Ugh. Your body is now the host for germs to grow and reproduce. OMG. As the germs multiply, an army of macrophages is called into action. Macrophages are members of the SWAT team that attack all foreign materials entering the body. Okay? The macrophages recognize that germs are not part of you. Who is this? He shouldn't be here. She shouldn't be here. Get it out of the body. Get it out of the body. We don't want the germs. Get it out. Get it out. Okay, so that's their job. Okay? So, the macrophages recognize that germs are not part of you, and they gobble up the invaders like tiny, hungry monsters. Their weapon and tactic is endocytosis, the method many cells use to engulf substances and bring them inside the cell. Once the germ is taken inside the macrophage, it is destroyed. I like that second line of defense. Let's take a look at this image here. Okay. So you see how it engulfs and destroys foreign particles that come into the body. Okay, right here, several germs have been engulfed by a process called endocytosis. Once inside the macrophage, the germs will be destroyed. Second line of defense. Love it, love it. All right, so let's head back. We have our first line of defense: skin, nose, airways, okay? And then, if it gets past those, then we have the SWAT team that shows up, all right? And through the macrophages, there are members of the SWAT team. They attack all foreign materials entering the body. They use a tactic called endocytosis. Let's take a look at this image here. Check this out. Actually, let's look at it this way. Okay? So the macrophages engulf and destroy anything that is foreign to the body in a process called endocytosis. Check this out. Oh, we have someone that shouldn't be here. It's called a germ. Let's take them out. So here we go. The germ gets sucked in. Oh, snap. You see how they go around right there? What? Cell membrane opens up, takes those in. Here we go. And it gets engulfed, and then it gets destroyed. All right. Let's take a look at a video clip of this actually happening.
Opportunistic and pathogenic bacteria that penetrate past the epithelial barrier, entering the bloodstream, are efficiently killed by macrophages. It is clear that the immune system is not ignorant of their presence of bacteria, because a vigorous IgA response directed against these microbes can be measured, and a significant proportion of this IgA is induced through a T-cell independent pathway. This high-speed video shows a macrophage chasing down planktonic bacteria. This is likely a segmented filamentous bacterium, as it appears to be attempting to escape capture. Eventually, the macrophage is able to phagocytize the bacterium. An optimally functioning immune system is required for such events to occur in the body. In the next video, we observe a different scenario. In this second video, you can see a red blood cell infected by mycoplasma with the characteristic bumps. Two macrophages are attracted to the infected cell. As one macrophage is aggressively moving towards the cell, it is joined by another macrophage. The second macrophage is immediately repulsed from the mycoplasma-infected red blood cell. The first macrophage makes another attempt from a different direction. Eventually, both macrophages move quickly away from the mycoplasma-infected red blood cell. Molecular mimicry of host molecules enables bacteria to display surface molecules resembling those of the host. This contributes to immune hyporesponsiveness to bacteria. Recent analysis has revealed the presence of secretion systems in commensal bacteria. Previously, such secretion systems have only been described for pathogenic bacteria. Opportunistic bacteria also use analogous secretion systems to deliver effector molecules that subsequently mediate their evasion of immune surveillance mechanisms in the body. This typifies the interaction between microbes and immune cells at the cellular level in immune-compromised individuals, where immune cells are rendered incapable of protecting the body.
All right, very interesting clip. Very interesting clip. Let's now look into TCI. We have an animation that I would like for you to see of this process. Okay? In this animation, the bacteria is represented by the tan blob that the membrane folds around, making a vesicle. All right, so you see this process, endocytosis. Check it out. Opens up just to take it in and close right back up. Okay, and here's another image. All right, taking a look back at the reading while the macrophage attack is going on. Okay, so say this happened in your hand. Your finger may be getting warm and red. Okay, so you'll notice where the germ got in. This happens because cells in your finger that are damaged by the invading germs release a substance that causes blood vessels to leak their fluid into the surrounding tissues. The fluid causes your finger to swell and makes the infected area warm and red. So have you ever noticed that feeling when a germ is inside of your skin and you look and you're like, oh, it's red, it's puffing up? That's what's going on. Heat and swelling help to slow down the germ invasion. Okay? You may notice pus forming at the invasion site in your finger. Pus is mostly made from dead cells, the casualties of war. It shows that your SWAT team is battling the infection. All right? So pus is actually not a bad thing. It's just a sign that the SWAT team is at work. If any germs escape from the macrophage attack and spread to other parts of your body, the next line of defense is ready to take over the fight. Those SWAT team members have been waiting patiently. Oh, okay, so you got through the first line of defense. Oh, you got through the second line of defense. All right, fine, let's go. You want a piece of me? Right? Basically what they're doing. So here we go, calling for backup. While the macrophage battle is going on, 3 other members of your SWAT team are gearing up. Dendritic cells, T cells, and B cells. Each of these members has a different job. How does each member use its weapons and tactics in battle? All cells have identity tags called antigens, which are mainly proteins found on the outside of their cell membranes. Although viruses aren't alive, they too have antigens in their surface. Antigens on germs can help other cells to identify what kind of germ it is. After a dendritic cell eats up a germ, it sticks the germ's antigens onto itself. The dendritic cell uses this to tell the other SWAT team members, hey, Look out for germs that looks like this. Dendritic cells specifically alert another SWAT member called a helper T cell that your body has been invaded by that specific kind of germ. Helper T cells then signal B cells to make antibodies against that antigen. Everybody is going to work. Antibodies are immune system structures that attack germs with specific antigens. There are millions of different kinds of antibodies, each one with a different target. Antibodies are so specific because each kind of antibody has a unique binding shape that combines with an exact antigen shape, like a specific key fits into a lock. You can think of the antibodies as the drones of the SWAT team. They search out the germs with matching antigens, lock into them, and mark them for destruction by T cells. So here we go. Here is an image. Looks a lot smaller here, so I'm going to keep it on a large screen. So we have the bacteria, right? It's still trying to take over. We have something for it. Third line of defense. Here we go. A dendritic cell alerts a helper T cell to an invasion by showing an antigen of the chewed up bacteria it caught. Helper T cell, see that? Okay. Then the now activated helper T cell goes on to activate a B cell. All right. All right. And activated B cells produce antibodies that recognize the antigen and mark that specific bacteria for destruction. All right, so now this is a visual of the process we just talked about. All right, so dendritic cell to the helper T cell to the B cell, and the B cell creates the antibodies. All right. When the war ends, most T cells and B cells die and are cleared away by macrophages. However, a few become memory cells, the final members of the SWAT team. If your body is invaded again by the same kind of germ, check this out. Memory T cells will remember them and attack. Hey, this looks familiar. Didn't we just have a battle with this germ last week? Yeah, can you believe this? He's trying to come back. But, I mean, we destroyed his cousin. We destroyed, why would he do that? I don't know. Maybe he wants to continue the battle. They haven't given up the war. Well, guess we're going to have to fight again. Are you ready? Always. So that's what they do. Okay? So now, this memory T cell will remember them and attack. Memory B cells will recognize the germ's antigen and quickly make antibodies. You develop immunity against a kind of germ when your body makes memory cells in response to a first attack by that germ. And this way you can gain protection against that germ for a longer amount of time, often many years. Shout out to the SWAT team. All right. Boot camp. Can you develop immunity to a disease without ever getting sick from the disease? And this is a hot topic right now. Yes, you can. Medical researchers have produced vaccines against many germs, and this is what they're working on right now for COVID-19. Okay. A vaccine is a preparation of either dead or weakened germs that produces immunity in the body. You have probably been vaccinated against diseases such as measles, mumps, chickenpox, polio, and maybe human papillomavirus. If you have up-to-date vaccines, you are now immune to those diseases. You won't get them even if the germs that cause them attack your body. Why not? Okay, so again, we talked before about going to the doctors and you get your vaccinations, different points of time. at birth, people get vaccinations, and then different stages, you get vaccinations for different things, and over a period of time, that creates an immunity to those diseases, all right? Think of a vaccine as creating a boot camp where the T and B cells in your SWAT team get training and fighting off the specific germ in the vaccine. Although the germs in a vaccine can no longer cause disease, they still have antigens that T cells recognize. After you get the shot, I'm pretty sure you've been to the hospital and you're like, oh, it's going to give a little shot. It's not going to hurt. It's only going to take a second. You're probably sitting there looking at the doctor like, or you might just, ah! Okay, I've seen that before too with my own children. All right. So after you get the shot, your T cells practice their tactic of recognizing the antigens in the vaccine. B cells practice making antibodies against the antigens, and both T cells and B cells become memory cells, right? That's the point of the vaccine. While these memory cells are around, you never get the disease that the vaccine protects against. However, some vaccines require booster shots because the memory cells will eventually die in your body and they need to be remade, okay? Vaccines can protect more than just the person who gets the shot. In a community, germs spread from person to person, but they cause disease only in individuals who do not have immunity. If enough people get vaccinated against a germ and become immune to it, the path of infection becomes blocked and the germ cannot spread to people who cannot get the vaccine, including certain people who are very young, very old, or very weak. These people without immunity can be protected even though their SWAT teams have not been called into action and have not made antibodies. This indirect immunity, which occurs when the vaccination of a portion of a population provides protection for individuals who have not been vaccinated, is called herd immunity. You share your world with germs of all kinds that live in the air and on surfaces in busy places such as subway stations and schools. Hence why we're out of school right now, because of what's going on. And yet, you rarely get sick. You can thank your SWAT team for keeping you healthy. It is well trained and ready to battle any germs that attack your body. So at this time, let's just give a shout out to our SWAT team. Thank you, SWAT team, for all that you do for all of us each and every day. You know, don't give as much credit as they should. They don't, you know, but today is the day to give a shout out to the SWAT team. All right, so that's it for today's lesson. Make sure you keep this in mind, right? Quick review, we talked about first line of defense. We talked about second line of defense, third line of defense. First line, skin, nose, airwaves, okay? And then we have the SWAT team for the second line of defense, all right? If it gets past the first line, skin, nose, and airwaves, okay? And so then we start off with the SWAT team. All macrophages are members of the SWAT team that attack all foreign materials entering the body through a process called endocytosis. All right. And then we have the call for backup. That's the third line of defense. All right. 3 other members, dendritic cells, T cells, and B cells. It's third line of defense. All right. And they do their job. Check them out here. Okay. And then the final members of the SWAT team would be the memory cells, final stage, so final defense. We have 4 stages of defense for our body, all right? And then boot camp is what medical researchers do to produce vaccines against many germs, all right? So we should be good to go for this section. Thank you for reading further for our lesson 7. We are now complete with lesson 7, parts of a cell. Give yourselves a round of applause, literally. All right, and we can close out at this point. Here we go. It's been fun. It's been real. We break it down and pick up science skills. Give yourself 2 claps just for tuning in. Come back, meet tomorrow. We can learn again. Oh, it's been fun. It's been real. We break it down and pick up science skills. Give yourself 2 claps just for tuning in. Come back, meet tomorrow. We can learn again. I'll see you all tomorrow. Peace.